out there who is one of those people I was talking about, and you had a teacher that never made you do this before? Guys. Then I will apologize. Guys, I will apologize for that bad teacher. Not for me, because I'm timid. You got to at least see once where something comes from, because then you will understand the idea behind it better. We're going to use the hell out of standard deviation. It is one of the most important numbers in statistics. So I'm only going to make you do this on the chapter 2 homework and the first test. After this first test, I'm going to let you calculate standard deviation for a list of data straight from the calculator. And I'll show you how to do that. Maybe today. We'll see. All right, so let me catch up to you guys. I didn't do any of this shit, so I'm not going to copy all this stuff down. So you should have been able to get all this stuff in there. If you did put it in order, it would have been a 2 and then some other stuff. The mean should have come out to be 6.5, right? So I said do not round. So on a test or something, I will tell you where to round to. So you're not like, I got 18 decimal places, Jeff, is that enough? So I'll tell you where to round to. Blah, 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 blah. In fact, let me do this. Just make sure everybody's with me. All right, 6, 7, 4, 6, 9, 4, 10. Everybody? Yes. Let me sort that just because. Okay. Yeah. So then if I do L1, oh, you can't even see that. That's useful, Jeff. All right. There we go. So if I do L1 minus 6.5, bang, and you just got to copy that down with me. And then if I do, I want L3 to be the square of these guys so I can kill these negatives. So L2 squared. Bang. So hopefully those numbers look familiar. You guys doing all right? Somebody looking at me like they thought they were in cooking class or something. What are we gonna milk butter? No, it's not gonna happen. So if I come out of here, then I can go back to list. And you don't have to do this all the time, but just here I'm gonna do it. If I sum up L2, if I understand the idea, I know that that should come out to be 0 or close to 0 in case in the future I round. This should be exactly 0 because we didn't round at all. I like it. And then I can do, I want to sum up L3. Sum kind of sucks. Gotta go in a list and go math. So if I hit second enter, it brings up the last thing I did. I can go back and change that to L3. Yay. So that second enter thing kicks a lot of ass. Because if you do this huge equation, you're supposed to put a minus there and you put a plus, you just hit second enter, make it a minus, yay. Instead of putting the whole thing in again. Okay, so now I got that. That is the sum of all those squared distances. Wherever I see this whole thing in an equation, I'll replace it with 69. So up here, I don't put anything in there, I don't put anything, this whole thing is 69. And what's n? 12. So 12 minus 1, 11. So you get like, what was it? 2, 7 forever. Right. Let me just do it here real quick. Come back. What's the next thing I want to do? What is that, by the way? What is that? I already said. It's the variance. I forgot. I put the word there. So before you take a square root, it's called the variance. Later, the book will sometimes be mean and give you the variance, and you have to square root it before you do anything with it. It's a little bit mean, just got to pay attention. To get the standard deviation, I got to take the square root of all this mess, and I'm just going to hit square root, and watch this, kind of nice. Second negative, this ANS, always has the last number that showed up on the screen. It's a memory position. It's one of the most useful little things. Oh, holy shit. Okay, so everybody pretty much I saw got this. That is my standard deviation. That is how far, on average, the data points get from the middle. Now this thing is, now what I'm going to do, what I often reference standard deviation as is steps, how big each step is. And it will eventually make more and more sense. But right now, if my data is really spread out, if my data looks like this, wow, I want to take kind of bigger steps to get around it. But if my data looks like this, and if I take that same big size step, I'm going to miss most of the freaking data if I take that big of a step. Standard deviation is a relative distance. I always call it the size of the tick marks on your ruler, right? So on a ruler, it's set to be inches, but in a different country, like any other country in the face of the earth, it would be centimeters. You guys kind of with me? So I can pick one or the other to measure the distance. Would I measure the distance between people in this room using miles? Could I? Yes. Would I? Hell no. I might use inches. Maybe feet, right? I'm talking about people. You guys kind of with me? I really want this to make sense. Standard deviation is a unit of measurement like inch that I can choose to measure how far things are, relatively. So if I have data that's like this, these two things might be one step apart. How big would the step be here? Much smaller. So that would still be one step apart, but a lot closer. Because relatively, they're much closer. So it's sort of like, is our sun very far away from Alpha Centauri? Anybody else know what Alpha Centauri is? Besides, it's not just science fiction, it's like the next closest star. So it's not very far away relative to how far stars are. But it's freaking 4.5 light years. It takes light 4.5 years to travel from there to us. So just by itself, that's pretty damn far. You guys kind of with me? So, but relative to how far away all the stars are, that is freaking close as shit. Most stars are like way further than that. So this standard deviation is a relative distance I could use to see how relatively far apart two things are. Relative to what? Relative to the data. Right? So if you got a raise of $3 an hour, wherever you work, would that be a good raise? Yes. I'm pretty sure none of you are like Zuckerberg level entrepreneurs and, well, you know, make $1 billion a year. So, but yeah, if I was making $1 billion a year and somebody's like, I'll give you an extra 100, doesn't mean shit to me. Relative to where I am, that doesn't mean shit to me. Right? But if relative to where most of us are, $100, yeah, man, that's awesome. Okay, maybe not. Okay. So what I'm doing on this next problem is I'm using this to measure how far apart a data point is from the mean. So how far is 10 away from the mean? Well, it's 10 minus the mean. But relative to how far the data is in general, so divided by 2.5, how many steps fit in between those two is really what I'm asking. And it should come out to be a little less than, what is that? 2.59, 3.5, what's it come out to be? 7/5, 1.4? 1.397 to be precise. I like it. So that 10 is 1.397 steps above the mean. That's what that says. That's what that means. So it kind of makes sense. I use the step size based on how spread out my data is to walk around my data. So how many steps does it take to get from 6.5 to 10? 1.397. What if my step size was 30? Then it would take from 10 to 6.5 would be like nothing, would be so small. Okay, maybe. All right, so this will become much bigger later this semester. Right now I'm just going to tell you, this is what's called a z-score. So a z-score tells you the number of standard deviations from the mean to a data point. Okay. Maybe. Now. So if somebody had a bag that weighed 10 pounds and they said to somebody else, here, hold this, the other person doesn't know how much it weighs, and they're like, guess the weight within 2 pounds. So remember, we know it weighs 10 pounds, and we give it to somebody, and we're like, here, if you guess the weight to within 2 pounds, I'll give you $1. Right? And you're like, sweet. Right? How far off can he be then? From between what two numbers would he get $1 for saying? 8 to 12. So what does within mean? That much up and that much down. So if I want to be within 1 standard deviation of the mean, that means go up 1 standard deviation, go down 1 standard deviation. So what's the mean?
6.5.
6.5. Put that in the middle, because that's the measure of center. Go up 2.505. And where do you end up?
9.005.
Kick ass. Go down 2.505. Sorry, bud. Go ahead.
3.995. My apologies.
You're all right. don't even do that, guys. Is everybody good with where I got those numbers? I ask this kind of question on basically every test because this is related to a lot of theorems in statistics about what percentage of the data do I catch when I go out so many steps, right? It's why the bell curve is shaped the way it is. Where is 1 step? Where's 2 steps? Where's 3 steps? They're always relatively in the same place, no matter how fat or skinny the thing is. Now the next question is kind of weird. Did I catch the 2s in here? No. Did I catch the 3s? There are no 3s, so I didn't catch any. Did I catch the 4s?
Yes.
Yeah, so I caught all the 4s, all the 5s, all the 6s, 7s, 8s, 9s, but I didn't catch the 10s or the 2s, right? Do you guys see what I'm saying? So how much did I catch? What percentage? So I caught, let's see, I didn't catch the 2s and I didn't catch the 10s. So there's 3 things I didn't catch. So there's 9 things I did catch. Is that cool? So I caught 9 data points out of 12. 9 12ths is 75%. So I caught 75% of the data within 1 step. Here. Okay. We did it somehow. Now you guys have to go and make sense of it. So this is the practice test. I am going to have an answer key for this Thursday. The test is next Tuesday. You don't have to do this at all if you don't want to. It's just sort of to let you see how I set a test, to see the kind of questions I ask. And I'll have the answer key next time. Don't give this back to me. I got enough paper. I'm going to give you the answer key. I don't need this.